Before we start the 5.6 notes, I'd like to just quickly go over, this is actually what, if you were in class, what we did right before Thanksgiving break, but just remember how to simplify radicals. Okay, this first radical over here, this is not on your notes. You can write down if you want to or just watch. What is the little number that's right here for this one?
1.
It is an invisible 2 because it's a square root, so it's 2. That number, whatever it is right there, is called the index. So the index here is 2. All right, so when we break down this 150, we're going to look for sets of how many numbers? 2, whatever that index is. Okay, so let's break down 150. What can we break 150 down into? 10 and 15, all right. What can we break 10 down into? 2 and 5. What about 15? 5 and 3. Can we break them down anymore? No. So at this point, do we have a set of 2? That'd be the 5s, right? So the 5s come out to the front, and just one of those. And then what's left inside?
6.
2 times 3, which is 6. Hey, some of y'all made the mistake of the 2 and the 3 there. You would add them, and so you write down 5, and that was incorrect.
Yeah, you had me confused on the 3 thing.
Is it better now that you multiply them
Yeah,
to get 6?
now.
Okay, now the other part is the a over here. A cubed, how many a's is that? 3. 1, 2, 3. I think that's the easiest way to do it. It's just write them out. So we're looking for sets of 2. So here's a set of 2, and then we have 1 left over. So what's outside the radical? 5a. And then what's inside? 6a. Okay, this pair brought the 1 to the outside, and this leftover one left 1 inside. So that would be your answer. 5a square root of 6a.
What if you didn't have 3A? If you just had like 1.
What if you had 5?
If you just had 1, it would stay on the inside. If you just had 2, it'd be
1 on the outside.
just 1 on the outside. I've got another one to show you too. Let's do the next one and then see if we have more questions. So this time, what's the index? 3, so we're looking for sets of 3. All right, let's break down 125. What can we break that down into?
5 times 5 times 5.
Yes, so 5 times 25, and then you can do 5 times 5 times 5. That is fine. I was just helping us think through it. Okay, so do we have a set of 3? Yeah, so what comes out? A 5, but we still maybe have something else. The b's, let's see, we have 7 of those. 2, 3, 4, 5, 6, 7. We're looking for sets of 3. So there's a set, and 1 left over. So we have 2 sets of b's, so what will be on the outside?
B squared.
B squared is correct. For b times b. So b squared, and what's left inside?
No, should be.
Just 1 b. The 25, we broke it down, so that's already been taken care of. And that would be your answer. Any questions? Any questions about simplifying radicals? Make sure another common mistake was that if it starts out with a 3 up here in your answer, you have to have the 3 in the index. Okay?
What about the 2?
The 2, well, the 2 is like the assumed one. It's invisible. You can write it or not write it. 2 is special. But everything else, it has to be there. All right, well, let's go and start the note. Today, we're actually breaking it into 2 parts. We'll do the front of the notes and a little bit of the back, and then we'll save the rest for tomorrow. But what we're talking about today are complex numbers. Complex numbers have this structure, A plus BI. So we normally have numbers filled in for A and B, but we have this I. I is not a variable, it is a number. It is an imaginary number. And we'll learn in a minute a little more about that. But complex numbers have real numbers in front and then an imaginary number added to it, or subtracted, either way. So examples of complex numbers would be like 3 plus 2i, or 7 minus I, or I'm just making all these up, negative 4 minus 16i, or just I, or just negative I, or negative 10i. Just making all those up. Okay, so anything with an I is a complex number. Even if it doesn't have a real number in front, it's still considered complex because it'd be like 0 plus I. All right. Now, what makes an imaginary number imaginary? Can you take the square root of a negative number, like square root of negative 9?
3 and 3.
Well, what's 3 times 3? Positive 9. What's negative 3 times negative 3? Positive 9. There's no number that you can square that'll give you a negative. So we cannot take the square root of negative numbers. So what we do instead is we replace it with an I. So I equals square root of negative 1. That is our big thing that you have to remember. I equals the square root of negative 1. And we can use that to help us take square root of negative numbers, like square root of negative 100. We can break negative 100 down into 100 times negative 1. Okay, we can do that with square roots, break them into 2 pieces. Well, what's the square root of 100? 10. And then what do we say the square root of negative 1 is? I. So our answer is 10i. Okay, so the next one down here, square root of negative 25, we can break down into square root of 25 times the square root of negative 1, and what would be your answer? 5i. Because square root of 25 is 5. Square root of negative 1 we replace with I. What will the answer be to the next one? 4i. Okay, if you want to skip steps, go for it if you understand that. If not, you can break it down. So square root of 16 times square root of negative 1. Square root of 16 is 4. Square root of negative 1 we replace with I. Any questions? I is not a variable, it's a number. Kind of like pi represents that specific 3.14 blah, 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 blah. I specifically represents square root of negative 1. So a lot of times there's like corny math jokes that instead of putting I in a sentence, they'll put square root of negative 1. Maybe I'll look some up for you sometime. I don't know. When I go to like math conferences and stuff, there's always corny jokes like that. Okay, let's keep going with ones that aren't perfect squares, like square root of negative 18. Well, let's break that down. So square root of negative 1 and square root of 18. We know what the square root of negative 1 will be. That'll be I. But let's go ahead and break down the 18. What can that break down into? 9 and 2. And then 9 breaks down into 3 and 3. I'm looking for sets of how many? 2. So my 3 will be in front, and then my I and a 2 inside. So your answer is 3i square root of 2. Does that make sense? Let's try the next one. So that breaks down into square root of negative 1 and square root of 12. What can the 12 break down into? 3 and 4. 4 breaks into 2 and 2. I've got set of 2's, and my square root of negative 1. So what is in front of the radical? And what's inside? My leftover 3. Still okay? All right, next one, a little bigger number. So we have square root of negative 1 and then square root of 72.
Oh, crap.
What is 72 broken down? 8 and 9. 8 breaks into 4 and 2, and that's 2 and 2. And then 9 is 3 and 3. So let's see, I've got a set of 2's and a set of 3's, a 2 left over, and my I. So 3 times 2 is 6. I square root of leftover 2. I highly recommend like marking your leftover numbers because that's usually where the mistake is made, is that we don't see those because they just kind of disappear into all the mess. Okay, if you want to box them in or star them or something, I just heavily underline mine. I just recommend that. Okay, the last problem I accidentally did a repeat, so we're going to change it and do something else. We are going to do square root of negative 10. Well, we break that into our square root of negative 1 and square root of 10. What's 10 break down into? 2 and 5. Do we have any pairs? No. So what will be in front? Our I, and then what's left inside? 10. So when there's nothing to pull out except for that I, that's all you got to do. Okay, if it's it only breaks down into prime numbers, then pull the I outside and leave everything else inside. Any questions? No? So, just to finish out my chart up here, example of complex numbers, we got, I don't know, we can do 5i, I square root of 3, negative 6i. I'm just making a few up to kind of finish what we started. On your homework, there's going to be problems that aren't exactly like what we did. It's going to ask you to simplify and then put it in this structure. That means make sure the real number comes first and anything with an I goes last. Okay? It's still just simplifying, but they just want you to practice putting it in this structure. I always goes last. Or the one with the I. Okay. To the back. We are just going to do this top portion today, and then we'll save the rest for tomorrow. So what did we say the square root of negative 1 is? I. Okay. That's I. Now, I squared is going to be, well, I is square root of negative 1, and then we're supposed to square that. Well, what happens between the square root and the squared? They cancel, and we're left with just what was inside, which is negative 1. So I squared equals negative 1. That's very good to remember, because anytime you're going to have an I squared, just go ahead and make it a negative 1. We'll deal with that a lot tomorrow, or some tomorrow. All right, the next one is I cubed. We can break that down into the two parts we already know, right? I cubed is the same thing of as I squared times I. So I'm going to say that that's I squared times I. And what was I squared? I just said you need to remember this. What's I squared? Negative 1. And I is I. Well, what's negative 1 times I? Negative 1i, which is the same thing as negative I. So we have I, -1, negative I. Let's see what will be next. I to the 4th. Let's break that down into I squared times I squared. Since we know I squared is pretty simple. I squared equals -1. That was not as exciting as I wanted it to be. That's okay. So -1 times -1 equals +1. So we've got I, -1, negative I, 1. Now, huh?
How nice.
How nice. Now the I to the 5th, let's break it down. I to the 4th is pretty simple. It's just 1, correct? So let's break it down into I to the 4th times, what would it be timesed? Just I, because we need 5 of them. We've got 4 and then 1. So I to the 4th is 1 times I gives us I. Next one for I to the 6th, let me zoom in some. Let's write it down as I to the 4th, and then what will our next piece be? I, what's left? I squared. What was I to the 4th? 1. What was I squared? -1. What are those together? -1. So we've got I, -1, negative I, 1, I, -1. Ooh, what do you think the next one's going to be? Ha-ha! Catching on. Okay, so break down the next one. So it'll be I to the 4th times I to the 3rd. I to the 4th was 1 times I to the 3rd, which was negative I. So what do we get? Negative I. What do you think next one is? 1. Let's see if it is. Okay, so I to the 4th times I to the 4th, because 4 plus 4 is 8. So that's 1 times 1, which is 1. So is there a pattern? Yes, what is it? I, -1, negative I, 1. And then it repeats. So what would...
Did you know that multiple dots means you're thinking? Yeah.
Or your...
My email,
What do you think I to the 9th will be based off this pattern? If it's
Or just I.
the next one, yep, it's just I. Yep, you can just put an I. Okay, now, what was I to the 4th? 1. What was I to the 8th? 1. So multiples of 4, since it's a pattern of 4, multiples of 4 will always be what? 1. Multiples of 4 will be 1. That's a 1. So, I to the 20th, is that a multiple of 4? Yes, so it will be 1. What about I to the 100th? It'll be 1. What about I to the 101?
Negative I.
I, negative I.
What comes after the 1? We restart the pattern, so it'll be I. So 100, I to the 102nd would be -1. I to the 103rd, negative I. So if we don't really get into really high exponents with i's, this is just showing you that in instances when you do, you don't have to completely work it out. You can just use the pattern to help you figure it out. All right, you don't actually have to do that on your homework. That was just extra exciting tidbit for you. So your homework today is 1 through 18 all, and it is due tomorrow. And then tomorrow we'll finish the notes, and you'll have another chunk of problems to do. Okay, so this homework is due tomorrow. Any questions? All right.